Hello and welcome back to the City Structures channel. We're on the ninth lesson on RC design with the robot software. In this lesson, we shall go through the provided reinforcement feature. We had briefly gone through the required reinforcement option in the previous lesson. In case you missed it, you can check it out in the lesson playlist. The provided reinforcement option is a powerful feature for designing individual concrete members. It allows you to customize the rebar configuration, spacings, anchorages, etc. Additionally, you are able to compare the reinforcement provisions with what is required using graphical displays. In addition, you can also generate drawings and calculation notes. You can use this feature to design a single member, or you can import a member from an existing model. Let's have a look at how to use it. The first thing you do is to transfer the elements that you wish to design. To do that, you just select it. So you can either select a beam, a column, or a slab, or even a footing, or a base. For example, if you select a base, you can just go to plan, then you select it like that. So it's going to select a node. Otherwise, you want to just demonstrate using a simple beam. Just select that beam. Then once you've selected it, you click on this icon here, or you can go to design, then select the provided reinforcement of RC elements. Just wait for it to transfer. So that is done. First thing, you're going to select the combinations which are going to be used in the design. So you can either use the manual combinations you had generated, or you can use simple cases. Now this one is going to use the load cases that you had created, the dead load and the live load and the wind load, etc. Then it's going to generate combinations automatically based on the design code. So I'm going to pick manual combinations because I had created some combinations earlier. Then I'm going to click on OK. Now immediately the element has been imported together with its properties. As you can see, we have its geometry here. It's 200 by 450. Then if you just extend this, you can see there's a green tick here. It shows that it has been designed automatically based on the default settings within the provided reinforcement option. So of course it might not be the one that you wish for. So the first thing, begin by setting up your own parameters. So you go to analysis and then calculation options. Now here you set up the first parameters. The general case, you can begin the cover. Just try an example. Perhaps just take a cover to the bottom and the sides to the top. It's 25. So you can fix them. Then deflection calculation. So in case there is some issue, you can correct it by reinforcement changing. Then deflection, you want it to be perhaps less than 25 millimeters, or you can pick a ratio based on the length of the beam. Then when you click on advanced, you can decide to redistribute or reduce the moments, the support moments, but you're not going to do that here. Also click on geometry optimization in case there are no limitations to the size of the beam or the shape of the beam. You can decide on perhaps if there's need to change the dimension of the beam. If the beam size does not satisfy the design, you can do that, but I'm going to keep them fixed. Next up, we go to select the grade of the concrete. I'll keep it as 25. These are the properties. So I can alter the aggregate size depending on the one that perhaps will be used. Moving on, go to longitudinal reinforcement. The first thing, you pick up the grade. Now I showed you how to determine or perhaps select the grades in the the second video of the series. You can check it out. Then once you've selected it, so I'm going to be using T grade, where it has a characteristic strength of 460. I'm going to select perhaps just 2 bars, T16 and T12. Then moving on to transverse reinforcement, the same thing. This time I'm going to pick R steel. Then I'm going to pick out T8. For additional reinforcement, I'm going to apply T and pick out perhaps T16 and T12, for example. Then once I'm done, I can decide to save these settings in case I want to use them for another beam or in another project. So I click on save as, let me just say beam, and press OK. Then OK. So it has been provided, as you can see here, calculation, parameters, beam. Then you go ahead, you go to the reinforcement pattern. Now in this case, We're just setting up how the reinforcements are going to be applied on the beam or on the element. So we want it to be on the whole beam since it's just one beam. We want the main reinforcement 16. I'll keep everything here default. I won't change it. For the bottom reinforcement, this is now the layers. I want to create several layers along perhaps the length, not rather the length, the height and the breadth of the beam, as you can see. So I'll make it automatic just to be simple. Then for the top, I'll make it as bottom reinforcement. So you can check out these settings and just look at how you can modify them to your own liking. Then for transversal reinforcement, you can decide for the arrangement type to fit it to the envelope of the shear force along the beam so that it will provide spacings according to the variation of the shear strength or the shear force within the beam. Or I can pick up a constant segment spacing. In this case, I want to fit it to envelope. Then I can pick a spacing multiplication. This is now in the case where, since it's going to vary, it's going to pick out some spacings which are going to be multiples of a certain value. So I can say let them be multiples of 5 or 50 millimeters in this case. Then for construction reinforcements, there won't be much, perhaps for hanger bars, things of the like. So I'll just say as for main bars, you can check out these other settings, especially for example, transport reinforcement. This is for now precast beams. Then let's go to shapes. Now you can modify the shapes, the different steel. So for the main steel, I want them to have hooks at the ends, as you can see. Then construction wall, I'm not going to touch them. For the stirrups, I might decide that they have a hook of 135. Then just going back to transverse reinforcement, I'm going to pick out the layout of the shear links. So there are two rows here, this first row and this second one. So I'm going to pick out this one, remove this one. Then on the bottom, I'm going to remove this one and leave it this one. I just want them to have 2 legs. I don't want 4 legs on them for now. Then once I'm done, I can also save that. Let me just say, call it beam. Okay. Then okay. So immediately you can see it's changed here. Now I move on to story parameters. And this one, you change the environmental conditions and the fire resistance issues of the beam, or rather the element. So the environmental class will keep it as mild, depending on what you're dealing with. You can keep a fire resistance of 1 hour. Then the exposure, let's say just one face is being exposed. The maximum crack width, you can decide. Perhaps let's keep it as default. For the exposure, you need to be the element to be in the exterior part. Then coverage or concrete edge of loading, let's take 28 days. Then you can also save this just as beam. Okay, then okay it. Lastly, we have the drawing parameters. In this case, you can either pick a template or you can edit one that is already there. In the case I was going to pick a template, just going to show you where you edit, then how you can use it. So the B is meant for beams, so I can just look for one like that. Then I click on edit template. So these are the different areas within the template. Now to just find out what do these areas stand for, you can click on it, then click on these properties here. This is for the beam elevation, so let's keep it as that. It's going to show me the whole profile of the beam. Then I just want the sections, so hopefully this is the section here, the beam section. Then there's another beam section here. So in case you want to create your own, you can click on new here. Let's save that. Then you can let's create, begin with the area. So you just create your own customized one. Then you add everything you wish to add. Once you've done that, you add the beam. And this is right click and just see the properties here. This is now the whole layout of the beam. So you can select from here. Just clear that first. I want a beam span. Then I add it like that. Next up, I can add a section. So I look for a section here. It's this one. I'm going to add it. Perhaps I place it down here. If I wish to copy it, just perhaps I want to have several sections, can go to edit. Once it's selected, copy it, then paste it, move it to the side like that, copy it again, paste it to the side, or something of that kind. If I want to add text, I can click on new text here, just perhaps move it here, then I can double click on it to specify what it's going to be. So for example, I can pick out a variable, you can say project name, so the project name is going to be, or we can generate a function just based on these inscriptions here. Now you can see what this function is about, so it tells you what you're going to find as the output of that function. So that is done, you can now go ahead and save it to use it as your own template. I'm not going to use that, I'm just going to use one that I had created prior. Then I'll show you how to edit other parts of it later on. Then we can move on to reinforcement description. This is now perhaps when you're sectioning, or rather the properties within the drawings. You can define the number, diameter in this manner, so 3d12 or diameter 12. Then the length, if you want to also view the length, the bar. Then the spacing, the bottom. Then the presentation for the straight bars, you want them to be visible in this way so that you can find a distinction between them. Then the presentation of the stirrups, prefer this one at the top. Then the scale, I'll keep it as that. The reinforcement table, now this is for the things like bar schedules. So what do you want to have in the table? Perhaps I'll just leave this like that. Then you can also go ahead and save it as a template. It's just write beam, then OK it, then OK. Now so everything has been set. You can go ahead and click on start calculations. I'm not going to tick on this because I first want to check out if the results are okay before I start drawing. So I click on calculate. So once it has shown me the green tick, it's okay. Now just to see how the reinforcement is, you can go to beam reinforcement here. Now on this 3D view, you can see how the reinforcement looks like. You can just even rotate it to see how the steel has been arranged. In case there are modifications you wish to do on the bars, you can go to this table down here. You can select. Now once you select, the bar is going to be highlighted on the model. Then there's also at this point. So as you can see, there are axes here, or rather graph. It's placed in a graph where you can now look at the positions, the actual positions of the bars. Now in case you want to edit them, their positions, to move them down or up, depending on what you're looking for, you can edit them. So to do that, perhaps I want to reduce the hook length of this bar. So once I have it selected, I have this window here. So I look for the hook length on the left end. Perhaps I want to reduce it to 0.1. Once I do that, and perhaps that adjustment is not going to be good for the design, it's going to indicate it to me. Then also the beam is going to now be marked yellow. The tick is going to be yellow to show me that the design is not correct, or rather there are errors. So now I can, perhaps let me go to 0.3. Rather I've changed the wrong thing. I'm supposed to change the hook length to 0.3. I've actually adjusted the wrong option. This is supposed to move this close. It's supposed to be 0.03 in this part. Yeah, like that. So as you can see, I've reduced the hook length, and I've also been able to move the bar. So I can do the same with this bar, the bottom bar. Let me just reduce the hook length. The left end, perhaps I just want it to be 0.3 also, like that. And if I want to add hooks, perhaps on this bar here, that's an assembly bar. It's like just a hanger bar. It doesn't really do a lot of resistance, or rather provide any resistance to moments. Then also you can filter out the different steel. For example, I can remove the structural reinforcement that is now for the hanger bars. As you can see, it's been removed. I can also, perhaps if I want to just view the longitudinal reinforcements, I can also remove the transverse so that I can view only the main reinforcements, like that. I can decide perhaps I want to move this reinforcement perhaps to be closer to this one. To do that, I can select this one, just figure out where the bar is, the x-axis. So it's at 4.88 meters. If you're not sure where that is, you can just right click this model, then you're looking for ZX, so we want ZX, so you can be able to view the graph like that. So it's at 4.88, that point. You can zoom in. That's the furthest I think it can get. If we go any further, yeah, let's keep it at that point. So I want to move this bar to that position, rather the right part of it. So I go to the right end, I change the position X to 4.88, like that. Still I have to make sure this is on tick. Then if I want to add another bar, I can go to reinforcement. So I can add a new bar here. So I specify everything. Then I can specify the position and click OK. Then I'm going to add it. You can also translate or rather move other bars within the already present bars here. Then if you want to check on the perhaps the economy of the bars that has been provided, you go to beam diagrams. Now here you're going to find graphs. Now not only for just the results, but also for the forces within the bar, or rather within the element. So you can decide you want to view the bending moment. So it depends on if you've done any distributions, and also you can look at the capacity of the beam. So let us look at, we're going to click on these two, rather they're already selected. Click on apply. That's the graphs I'm going to see. So the bending moment within the beam. So you can even use this to obtain the data, perhaps to perform your own calculations outside the software. Then moving on to reinforcement. In this case, it's already selected. You can just take a look at it. This is how it looks like. So the blue one is the required reinforcement. Let me just remove the provided ones first. This is how the provided reinforcement is along the beam. Then if I add the provided reinforcement, it's just going to show me how they overlap each other. So as you can see, the red one, that is the provided, is overlapping the blue one, which is a good thing. Also check out the ratio, rather the safety factor in which the reinforcement is being provided. So when you hover over the graph, there's this box that shows up. You can see the distance or the position I'm in. I'm at x is equals to 0.51. Then you can see the required reinforcement. So there are two. The first one on the left hand side, that is for the bottom reinforcement. Then for the minus, the one that has a minus at the top, that's for the top reinforcement. So as you move, you realize the top reinforcement is 0. There's no top reinforcement. Then as you begin, again, the top reinforcement begins to increase. Then also you can view, just move down just from the top, from plus, then you have the required reinforcement for the bottom steel. Move down the provided reinforcement, and then you have the safety factor or the reinforcement ratio. It's 3.82. So at this point, you're provided almost 3 times, or rather 4 times the required reinforcement for the bottom reinforcement. Then at the top, since there's no required reinforcement at the top, so it's going to be a dash. If you move to this side completely, now you can see how the top reinforcement has been provided. So it's around 1.2 times the required reinforcement, which is a bit okay. If you go to the midpoint, the midspan of the beam, just want to check out how much reinforcement has been provided. So it's around 1.4 times the required reinforcement, which is okay. Also check the same for the shear. So I've already activated for required. You can check out the provided, then apply. This is what has been provided, as you can see. On this side, I think these are at the ends, or rather near the ends. That's where a lot of reinforcement for shear is required. So as you can see, so what has been provided is 402.12 square millimeters per meter compared to what is required, that is 336 square millimeters per meter. So you can use these graphs to just compare and check out how your reinforcements have been provided. Then moving on, we go to beam note. Now here it just provides a report of the design that has taken place, the material properties, the calculation options, how the reinforcements have been provided, as you can see. So bottom we have 2 T16s, then we have assembling of the hanger bars, 2 T16s. Then at the support, we have several 2 T16s on either supports. Then the transversal, the shear links, so the R8, then also how they have been distributed along the bar or along the beam. Then material survey, the concrete volume, the formwork required, the total weights, the diameters, etc. So when you're going to drawing, of course you want to see the drawing of the beam, or rather before you go there, in case you want to have this report, you can just go to results and click on calculation note. Now here you specify what you want specifically. So we can look at perhaps those are the only things you want. If I click on OK, it's going to produce a report like that. Then I can go ahead and decide perhaps to just save as or print. It will print to something that I want, then I can save it. Then if I want the drawing, I can go to this option here, click on it. And this is how the drawing looks like. So I think it's only one page. So we have the bending schedule here. Then we have how the links have been distributed, as you can see. So a spacing of 225 before now the links begin. So we have 3 links at 250, then 3 links at 300, 3 at 250, 2 at 200. It goes on like that. Then you can edit the section position. To do that, you just click on drawing components, then select, then you right click, section location and scale. So you can determine the position of the cutting plane of the section and also the direction, like that. You can decide it to be perhaps of this distance, then OK. So it has changed, as you can see. You can do the same for this one. So this is the middle reinforcement, as you can see, section B. I do the same. Something of that kind, won't change much. Also do the same for this one. Like that. So you can decide to also save the drawing as a DXF, or rather you want to import it to AutoCAD. You can go ahead and go to File, then save drawing in a different format. Then you can decide it to be DXF, then you save it. You can open it up in AutoCAD later on. Then now let's go back to RC Design. That's pretty much how you design using the provided reinforcement. There are other options which you can look at, but this is just a basic introduction. So one thing I wanted to show you before we close is something we call typical reinforcement. Now if you select it, this option just allows you to specify your own reinforcement pattern into the element and later check its suitability. So you can create the settings. You can also save them for later use. In this case, you can use, you can perhaps perform a manual calculation, then just determine the required steel. Then you key them in here, for example. Then you, once you've done that, you click on OK. Then it's going to provide it. And also check. So I'm going to do that automatic check. Then once it's done, you can now compare using the graphs I had shown you. So that's it on provided reinforcement. If you like this video, you can like and subscribe to the channel. We're almost coming to an end of the lesson series on RC design with robot software. The next lesson, we're going to look at now creating reports and perhaps taking screenshots and photos of tables and images within the software. So see you in the next video.